Hey everyone, this is Noah Diffenbaugh at Stanford University, and I'm really excited to host this Hangouts On Air today to talk about new research that we have published in the journal Nature Climate Change, where we're publishing new findings about global warming, biofuels, and the volatility in corn prices. And we have one featured guest here in the Hangout right now. If you'd like to jump into the Hangout, please just +1 or comment on my post, and we'll get you an invite to jump in. So we have Cedric here from France. So Cedric, please go ahead and introduce yourself.
So hi everybody, I'm Cedric Lambion. I'm a French student in communication, and I focus my studies on awareness and education in sustainable development. So I'm bound to follow what the research is about climate change and such issues. So that's it.
Excellent. I'm very glad that to have you in the Hangout today, and looking forward to your questions. So I'm going to start with a brief overview of our results, because this is a new paper. It's been in the news quite a bit in the last couple of days, and I'm really excited to have the opportunity to talk directly without that filter of the media and blogosphere, and hopefully we can just answer whatever questions there are about the research in particular, or the general topic of climate change. So I'll just want to bring up our key finding here on the screen. And so what we've done is we've used a set of climate model simulations and an economic model, and then compared those models with observed climate data and observed agricultural data and observed economics data. And what we're trying to understand is how climate, and in particular climate extremes, affect the price of corn, and in particular the volatility in the price of corn. And so if you look here, the vertical axis is a measure of how volatile the price of corn is, how much the corn price swings from year to year. And the blue is the historic climate, and the red is the future climate. So you can see that the future climate causes the price of corn to become much more volatile. And this is essentially because the number of heat waves that occur in the U.S., and this is all, these results are all from the U.S. The number of heat waves that occur in the U.S. increases substantially with even just another 1 degree Celsius of global warming. So the first big result here is that global warming over the next few decades is likely to cause an increase in heat waves that's likely to cause an increase in the volatility of corn yields. And that volatility then is translated into increased volatility in corn prices. The second key component that we've looked at is the effect of the biofuels mandate, and that's shown in the hashed bars. So what the biofuels mandate does is it requires that a certain amount of liquid biofuels be blended into the fuels market. And so we find that the presence of this mandate causes the increase in corn price volatility with climate change to be even larger than it is without climate change. And you can see here the difference between the blue and red bars with the hashes is greater than the difference without the hashes. So essentially, this requirement that some of the corn, in fact, quite a bit of the corn, in fact, almost 40% of the corn in the U.S. currently goes into this energy market. So this requirement decreases the responsiveness of the market and increases the price volatility. So those are the two key results. Cedric, do you have any questions at this point?
No.
All right. So I think there are a couple of important messages here. One is that I was quite surprised that the climate would have the biggest effect. My initial expectation was that these socioeconomic conditions would have a larger effect than the climate over these next few decades. So my first big surprise was that climate had a bigger effect than the biofuels mandate, or we also tested the price of oil and also how integrated the energy and agricultural markets are. I see that Maestro has joined the Hangout. Welcome, Maestro. Good to see you again. How are you doing?
I'm doing great, thanks. Good to see you. Sorry I was a little late here. I didn't get the notice. I hope I didn't miss too much.
No problem at all. Cedric is here with us, and Cedric has introduced himself. We're just going over the results in summary, and for any of you who've just joined online, this is a Hangout on Air to discuss new results published in the journal Nature Climate Change, where we found that climate change over the next few decades is likely to cause a substantial increase in the volatility in corn prices in the U.S., and that the presence of a biofuels mandate exacerbate this effect of climate change by about 50%. Maestro, do you want to introduce yourself real quickly?
Sure. I'm Maestro. I'm a fan on Google+. I'm based in Paris. I'm very interested in climate change and in also energy solutions. So the whole biofuel thing really interests me quite a bit.
All right. Yeah, the biofuel aspect is interesting because on the one hand, there's the potential, especially if the indirect land use change can be reduced, there's the potential for biofuels to reduce carbon emissions for the same energy use relative to fossil fuels. So we were interested in, because the U.S. does have a biofuels mandate, we were interested to see how this might interact with climate change, and so this is where climate mitigation, the policies and efforts to reduce our greenhouse gas emissions, potentially interacts with climate adaptation, which is what do we have to do to respond to stress from the climate system. So this is an interesting result that the biofuels mandate essentially creates more stress from the climate system for the same number of heat waves and droughts and other stressful events for the corn crop in the U.S. The biofuels mandate makes the price volatility much higher, about 50% higher than it would be without a biofuels mandate. Cedric or Maestro, do you have any questions at this point?
Well, just a real quick question. In terms of the biofuels mandate, is there a provision in that legislation that asks or takes into account the effect on climate change, and is there any type of review procedure built into the legislation, or no?
Well, this is a great question, and there are legislative proposals right now to modify the biofuels mandate. And what we've tested is we've tested the full mandate on or off, no mandate at all. So we're kind of trying to constrain the boundaries in terms of that corn price volatility. So I think how we create policies that can respond to events on the ground, so to speak, whether they're socioeconomic conditions or climatic conditions, that's a great question, and certainly it's being explored in the U.S. Congress right now in terms of having more kind of dynamic a dynamic biofuels policy. I think one interesting aspect of our results is that, from the perspective of climate change, this energy policy exacerbates the impact of climate change in this particular sector. But if you turn the question around and look at it from the perspective of the biofuels policy, the impact of the biofuels policy on the corn market is likely to be very different with more global warming than it is now. So if you're looking from the lens of the biofuels policy, you might not see this as being a big factor if you're just looking at today's climate. So how we kind of look forward and integrate potential climate change into the policies that we enact is a great question. I'm not a political scientist or a policymaker, but I think that certainly our results suggest that we're likely to see more stress from the biofuels mandate with another degree of global warming than we see right now. Does that answer your question?
It sure does. I'm just curious if this report that you've done sounds very interesting. Do you have a link to the abstract or to the report that you're going to be publishing?
Yeah, I can definitely send out a link to the abstract and to the journal webpage.
Okay, great.
I do have some of the results here, which I can put back up on the screen share again.
Oh, that would be great.
So this was the figure 1, which quantifies the response of the corn price volatility to these different factors. And actually, here's the reference, and the DOI is there at the bottom. So we see about a fourfold increase in corn price volatility resulting from climate change over the next 3 decades or so. And that comes from a doubling of the volatility of corn yields, and that volatility in corn yields is coming from an increase in the number of severe heat events that happen during the growing season. So if we look to the future, we see that this amplification of corn price volatility is larger with the biofuels mandate, which you see in the hashed bars, than without the biofuels mandate. So the difference between 192 and 37 versus 95 and 31 in this future economy. And then the vertical axis and the numbers above the bars are a measure of the price volatility. I think there are a couple of other interesting results, but I want to first ask if either Cedric or you or Maestro, do you have questions about what I have up on the screen now?
Go
ahead, Cedric.
Okay. I may have a question about the why of the comparison with or without biofuel. Because it appears to me that the biofuel mandate creates a stress on the demand. So this stress is maybe independent to the stress created by the climate change. So why linking the two in a single research?
Well, you've hit exactly at the key point here, which is that in the current climate, there's some volatility of corn yields every year, right? So, and in between the years. So we've looked at the U.S., which is the biggest producer of corn, and if we look year to year, in a good year, yields are high, and then prices are low, and in a bad year, yields are low and prices are high, and the weather in a given year really shapes whether it's a good year or a bad year. And in particular, severely hot years are associated with poor yield years because of the heat stress. So without a biofuels mandate, the yield goes up and down, and the price goes down and up. With the biofuels mandate, some of that corn is essentially required to be sold into the energy market because of this mandate. And so right now it's about 40% of the corn is being sold into this energy market. So that limits the ability of the market to respond to these swings. Right? So if there's a hot year and yields are low, there's still the requirement that corn be sold into the energy market. So I think that's the kind of the baseline situation that you were describing. Is that right, Cedric?
Yes, exactly.
So we're asking the question, given that we expect temperature and precipitation to change with global warming, how might those changes affect the yield volatility? That's the first question. And then the second question is, how might those changes in yield volatility affect corn prices, and in particular with this biofuels mandate? So what we find is that, indeed, the corn price volatility does increase as climate change intensifies, and this is because of the increasing heat waves. And then this interacts with the biofuels mandate. So just like in the current climate, if there's a poor yield year, which would make supplies low and prices go up, if you're required to still put some of that corn into the energy market, now it's an even lower year. And what we find is that in the future climate, there are more of these low yield years, right? And so then that's exacerbating what already is an effect on the price volatility. Does that answer your question, Cedric?
Yes. Have you calculated economical consequences of easing out on the mandate versus, I mean, people are working thanks to the mandate on biofuel, etc., particularly in rural regions, I saw. And if we ease out with the mandate, creating less stress on the corn, it will have an economical impact on those people working on biofuels. And what are the odds of this impact versus the impact of the volatility of the corn prices?
So for those of you watching live, we're talking about the effect of climate change on corn price volatility and how this interacts with energy policies, in particular biofuels mandate that requires biofuels to be produced. And Cedric is asking about whether or not we've calculated the economic impact of removing the biofuels mandate in terms of the biofuels industry compared with the economic impact of the changes in the corn price volatility. Is that right, Cedric? Did I summarize your question accurately?
Yeah, exactly.
So we haven't calculated the economic impact of say removing the biofuels industry, and really in calculating the effect of the biofuels mandate, we haven't actually gotten rid of the industry in our future that we're projecting. We've simply removed the requirement that a certain minimum volume of biofuels be produced. So in our results where we compare the effect of the biofuels mandate with no biofuels mandate, it's still possible in those model experiments for corn to move into the energy industry. It's just that it's not required to. So what happens is that the the marketplace decides how much corn goes into food and how much corn goes into energy. So there still is a biofuels industry in that economic simulation, and what we find actually is that the closer integration of the energy and agricultural markets actually decreases the volatility of corn prices. And we can talk about that result if you want. But I first want to check and see if I've answered your first question satisfactorily.
Yes, it's very good. Thank you.
Okay, Maestro, do you have any questions at this point?
Yeah, I'm sorry, I do. About the biofuel mandates again, so you mentioned it's roughly around 40%. I'm just wondering, is that a fixed percentage irrespective of the yield, if it's a good, a year with a good yield or a bad yield, or is there not some sort of set aside for the domestic, the natural domestic market?
Well, so this is a really interesting policy question. I'm not a policymaker or a policy analyst, but in the current construction, it's really the requirement is really a volume of liquid fuels. So it's not a percentage of the corn production that's required. It's a volume of liquid fuel that's required to be produced. And you can imagine that this would have very different effects, right? If there was some set aside and the requirement was that a percentage of the production be moved into liquid fuels, then we would expect to see less of a strong effect from that biofuels mandate, right? Because now essentially all of the volatility in yields has to be absorbed outside of that biofuels mandate, right? So if there's a certain volume of biofuels that has to be produced, then there's a certain volume of feedstock that goes into producing those biofuels, and then all of the volatility from year to year is felt in the rest of the market. So the way the economists talk about it is that biofuels mandate creates market inelasticity. Right? It decreases the ability of the market to respond. So we could imagine a lot of ways that there could be safety valves, release valves, where if the yields are below a certain amount, then that maybe less would be required to go into the energy market, for example. This is definitely not policy construction is definitely not my area of expertise. And again, we've tested the presence of the mandate versus not having the mandate at all. Does that answer your question, Maestro?
It sure does.
So I want to get back to this issue of integration between the energy and agricultural markets. This is something that is embedded in those results that I showed, and I think I'll put that screen back up again. So just to walk real quick, anyone who's jumped on the Hangout, we're talking about climate change and the price of corn, and in particular the volatility in corn prices, and how the U.S. biofuels mandate interacts with climate to affect corn price volatility. And this is a new paper that we have out in Nature Climate Change this week. So if we look in the current economy, this blue bar that has the 43 over it is the current simulated price volatility with no mandate in place, and the current climate. And then this red bar with the 177 over it is the corn price volatility that we simulate if we just apply the future climate, which is another degree or so of global warming, but much more frequent heat wave events over the main growing regions in the U.S. So this is about a fourfold increase in the volatility of corn prices just coming from the climate change over the next 3 decades. if we look at this, the two 2020 sets of bars, this is where we essentially run the economy forward using an economic model. And in this future economy, the agriculture and energy markets are more closely integrated. And what you see is that the difference between the current, the price volatility of corn in the current climate in the blue, say the 31, and the future climate, the 95, this is only a threefold increase in price volatility. So climate is still having an effect that's substantial, but this increasing integration between the energy and agriculture markets is buffering the effect of climate change if there's no biofuels mandate. So I want to I just said a lot, so I want to check real quick, Cedric and Maestro, is that more or less clear, that overview I just gave?
Yes, for me it is.
Yeah, but what's the reasoning for the lowering in the volatility of prices given the future climate, either with the future climate or the historical climate with the 2020 high oil scenario?
Okay, great question. So essentially, this energy market provides a buffer against the bad yield years, right?
Oh, sure. Okay.
And also provides a market to sell into in high yield years, right? So if the climate is relatively favorable in a given year and yields are high, the price will generally be low, and there's potentially a surplus of supply of corn. The energy market provides a destination for that surplus, right? So that price swing can be reduced by selling into this energy market. On the other hand, if there's a low yield year and supply is low, say there's a number of heat waves, drought, and corn yields are low, then the price without the energy market, without the biofuels mandate, then there's no requirement in a year with low supply that some of that supply be sold into the energy market, right? So you have a more dynamic market response where the increased integration actually does help to reduce the volatility, and that's without the biofuels mandate. Yeah, go ahead.
Yeah, but even without the biofuels mandate, wouldn't there still be a demand from the energy side?
Yeah, so so that's a market that depends on the market, and this is actually why we've tested high and low oil, right? So you see,
right,
you see in the middle the high oil, and you see on the right the low oil. And this question that you're asking about the demand in the energy market is exactly why we've tested high and low oil. And going in actually to the study before we did the science, my expectation was that the high and low oil would create much more sensitivity, say, than the climate change, because if oil prices are high, then the biofuels become quote naturally more competitive. If oil prices are low,
exactly,
then they become less competitive. So
right,
one might expect that the volatility with the mandate would be stronger in a low oil regime than in a high oil regime, and we do see that as a slight difference. This factor between 200 and 41 with the climate change is slightly larger than in the high oil scenario, but
right,
the difference between low and high oil is much smaller than what I had personally expected prior to doing the analysis. Does that help to answer your question about the integration?
It does answer the question, but my initial reaction then is that there's a higher degree of impact on volatility in the high yield years than there is from the low yield years, if I'm reading this correctly.
can you say more about that?
Well, just judging from what I'm surmising from these graphs, it would appear to imply that when you have a high yield year, that has a higher impact on the volatility of prices than the low yield years. Because my initial thinking was in the low yields there would still be increased volatility because of the increased demand for the biofuels, for the corn, for the biofuels, even without the mandates. But it doesn't appear to be the case.
So what I'm putting up now, can you see this new figure 2 that's different than what I was showing before? So this is
yes.
okay. So this is the probability density function, which is a technical term, but this is another result from the paper that's basically showing the likelihood that one has a negative year going to the left or a positive year going to the right, and it's relative to the year before. And there's a lot on here, but I guess it's probably worth walking through just what you're looking at. The black are various measures of the observed actual yield volatility from real yield data in the U.S. And then the blue are our 5 climate model simulations and what the yield that's calculated from those climate model simulations. And you can see that those the year-to-year volatility is pretty close between what we simulate and what was actually observed. The red is the future climate. So it's the same as that set of blue curves, but it's when we apply the future climate. And you can see that the volatility more than doubles for the yields, and that there are many more negative years. There are also more positive years, right? And that's what's causing this increase in volatility. The year-to-year swings are much larger. So that gives you a sense of what's happening to the yields with climate change. So before I get to the specifics of your question, is that generally clear in terms of what you're seeing on the screen now?
Yes, that graph is very, very helpful, this figure 2.
Okay, good. So essentially, when you have a year that's down here on the left, less than 1, this means that the yield ratio was negative compared to the previous year. And what we'd expect without a biofuels mandate is that the market then can decide relative to the price of oil and the other input costs how much corn to buy in to the energy market given the price, and the price is partly going to be a function of the yield in that year. So that's what's happening on this negative side. When the biofuels mandate gets added in, then the market essentially can't decide when there's a negative yield year. Then on the positive side, when we're over here on the right, this is what I was talking about before, where there's a surplus, and the integration with the energy market provides an opportunity, an additional market to sell that surplus into. All right, so does that help, Maestro?
Yeah, it does.
All right, looks like Cedric is out of the Hangout. So Cedric, thank you for joining us. I really appreciate your time and your questions. Maestro, do you have other questions at this point?
No. You said later on you will be posting a link to the abstract?
Yes, I will. Right when we get off, I'll post a link to the abstract, and that should be available. I can also the YouTube video will go up
Oh, great.
And there is one other component to the result that we could get here, if you're interested, real quickly.
Sure.
Then it'll be just for completeness. So the one other question you could ask is, well, if temperature changes and that affects the climate where corn is grown now, how might couldn't we just grow corn somewhere else? So we have asked that question, and that's what's shown on the screen now. So the probably the easiest to interpret is what's shown on the right, and the blue areas are the areas of the highest production in the U.S. for corn right now. So this is where most of the corn in the U.S. is produced, this corn belt. And we've asked, in this case, for extreme heat, since that's what really causes the effect that we're seeing on the corn prices. How far would one have to go to find the same climate that exists in the corn belt? And that's what we're showing in the red. And in this case, we're only looking within the U.S. That's an important caveat. But we're just plotting the same number of counties, essentially, the same number of grid points as the current corn belt, but in the future climate. So the red, when you see the red dots, the red are where the same year-to-year volatility of extreme heat occurs in the future climate just 3 decades from now, as what you would find in the corn belt in the current climate. And so what you're seeing here is that that climate space travels quite a bit. It essentially separates from the current corn belt. Is that more or less clear, Maestro? All right.
That's very clear, but I'm just wondering now, looking at this, does it mean that the you would expect that the yields in the future will be slower because it seems like there's a less, considerably less area that's suitable for optimal corn crops?
Well, so there are a lot of factors that go into yields, and climate is one of them. In this analysis, we're interested in the effect of the yields volatility on corn price volatility. So we're focused on the volatility in yields and what climate conditions create the volatility in yields. Certainly yields have improved as a result of agricultural practice, agronomic innovations, the availability of fertilizer and other inputs. So those are all factors for the overall yields. What we're really looking at here is the extreme heat and the variation in extreme heat from year to year. And this is where we know empirically, this extreme heat we know empirically is what has the biggest negative effect on yields in the historic climate. So we're not arguing that the U.S. corn production will move to these locations. We're simply asking the question, where is the same climate that the Corn Belt experiences now found in our future climate simulations? Where is it likely to be found with further global warming? Does that help to clarify things?
Yeah. Yes.
All right. Are there any other questions at this stage? We've run through the results of the paper pretty comprehensively, and I've really appreciated the insights and questions, and it always helps me to think about our results to get these kinds of questions. Is there anything else before we close, Maestro?
Well, I think you did a great job explaining the result of your research, and I'm just wondering if is there a next step? Is there a further research that this is going to lead to, or what are you planning to do next?
That's a good question. We're in the midst of it. So I think there are some important caveats, that we discuss in the paper of issues that we haven't addressed in the current research. I think, one issue that you raised that I think is really important and would be really interesting to test is kind of a more dynamic biofuels mandate. What would be the effect of having a mandate that was either less stringent in terms of the total volume of liquid fuels that we're testing, or more interestingly, could respond dynamically to the conditions that occur. And people have asked this question about oil price. So people have tried to look at the economic effects of a mandate that's responsive to the oil price. It would be really interesting, and this is actually not something that had occurred to me, frankly, until you asked the question of what would the effect on our results be of a mandate that was responsive to the yield volatility, in particular yield volatility in response to climate change. So I think that's a great question. And I've got to think about how we might test it. A couple other caveats are stock holding. How much, basically, how the individual responds to these market conditions. Do people hold onto their corn stock? Do they not? And I don't mean the biological stock, but the volume. Do they, instead of releasing it in the market, how do they respond to this volatility, and how does that affect the price volatility? And you can have similar questions about risk and how people view risk. So those are two questions that we identify in the paper that we haven't addressed explicitly. We also mentioned the oil price volatility. So we've tested high oil price and low oil price, but we haven't tested the oil price volatility in the way that we've tested the corn yield volatility. So that's potentially another important question for us to pursue. So those are some of them. Were those clear, more or less?
Yeah, it's very clear. I look forward to seeing the results of that. Maybe you can do another video when you have some more answers about those caveats.
Yeah, we definitely have some work to do on the science side to answer those questions, but we're working on it. And yeah, I really appreciate you joining the Hangout, and Cedric as well, and yeah, I'm stimulated scientifically from our discussion, so I'm excited to get back to the computer and jot down some ideas. So I want to thank you, Maestro, for joining, and thank you to Cedric for joining, and thank you to everyone who was able to watch live. And I will be putting out a notification when we have something up on YouTube, and I look forward to future Hangouts on Air. And if you have anyone out there out in the world has questions about climate change, suggestions for topics for discussion, I'd be very excited to hear them, and look forward to talking further in the future. So thank you all very much for your attention, and we'll see you out there soon.